Very good morning to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering, and I'll be dealing the subject robotics, and my today's topic is wheeled mobile robot. In the previous sessions, we have discussed about the various interactions between human and robot. We have seen about the intelligent robot. We have solved few problems based on the rotational matrix and all. Now, in today's topic, let us discuss about the wheeled mobile robot. What do we mean by the term wheeled mobile robot? Right? We have already discussed this in the introductory part. What happens when a wheel is being aligned to the robot? What is the use of aligning the wheel to the robot? And how does a mobile robot being operated in any organization or any particular industry? Right? So we will be seeing in detail about the wheeled mobile robot in today's session. Right. Coming up, the use. What is the use? That is generally this particular type of the robot is being designed to have a generalized mobility that can move on the surface or in water or in air. Right. This particular robot is being designed or it is being manufactured to have a mobility to move on the surface or in the water or also in the air. Right now, this wheeled mobile robot has the capability to move on the surface more considerably. Right, the wheel mobile robot has a lot of capability to have a smooth movement on the surface. Right, other than the wheel mobile robot, we also have an example of a automated guided vehicle. What is the use of an automated guided vehicle? Right, we have seen this is in the earlier two sessions back. Right, what is the use of an automated guided vehicle and how it is working? So this particular type of the vehicle is used for flat surfaces. Right, this particular type of the vehicle will have the wheels which can move conveniently on a flat surface. So that particular type of vehicle is called as the automated guided vehicle. Now, the robo which is having the n number of legs or which is having a hybrid setup being built for the automated guided vehicle. So those are most recently seen nowadays. Right, a robo which is having several legs or a combination of wheels as well as the legs. So that the robo which is having combination of wheels plus legs is called as a hybrid robo. Right, any particular robo which is being manufactured with the help of the wheels as well as with the help of the legs is known as a hybrid robo. That is, this particular type of the robo can be used on a smooth surface, or when we don't have a smooth surface, it can be lifted up and we will be operating that robo with the help of the legs. That is, the combination of both this particular type of the system is known as a hybrid system, which can be mostly used in any of the large scale industries. Like we also have the wheeled mobile robot, that is we call as WMR. Right, there is a vast majority of the wheel mobile robots being used because it has more efficiency and it can move faster compared to the other type of the robo. Right, the wheel mobile type of the robos have more efficiency and these particular type of the robos can move faster compared to the other type of the robo. No, not only that, the legged and raised vehicles can navigate through rough surfaces more easily. Right, now other than the wheel robot, the legged and tracked type of the vehicles can navigate through the terrain more easily. Right, this is about the wheel mobile robot. This is the general basic information about how the wheel mobile robot will be working and what is the difference between an automated guided vehicle and a wheel mobile robot. Right, now let us see what are the various applications, that is autonomous vehicles are used in which type of the applications. Let us see. Right, generally the autonomous vehicles will be used in the environment, that is industrial type of the environment, where we need to move the objects from one place to the other, or where we need to move any of the particular lump sum quantity of the goods from one place to the other. We can use this particular automated type of the vehicle, where on that particular robo we place all the objects, and that particular vehicle is being moving with the help of the wheel from one place to the other. Right, that is in the industrial environment we can use this particular type of the vehicle. Now other than that, we can also use this type of the wheeled mobile robo in the military and security application. This we have seen in the second class of our introduction class of robotics, that is in the military and security applications. When we use this wheel type of the robo, to this particular type of the robo, we have the sensor being placed, we have a camera being placed, and with the help of the sensors and with the help of the cameras, when the vehicle is being moving in the military area, the person who is sitting far away from that particular destination can watch where are the people being surrounded and how that particular vehicle is moving and in what direction it is moving. So it will be completely under the person's control who is far away from that particular destination point. So this particular type of the vehicle will be moving in the required environmental condition with the help of the wheels and with the help of the sensors. It sends the objects or obstacles coming across it, and it captures the images and send the result to the required destined person. Right. So we can also use the autonomous vehicle in the military and security application, which is one of the most important strategy. Right, and next we can also use in hazardous environment, where where a person cannot go personally and do some sort of work which is dangerous to him. So in that particular environmental condition, we can use this autonomous vehicle, that is in the hazardous environment like a nuclear reactor or in deep seabed. Generally, any particular person or any particular labor cannot go and work in those particular environmental constraints. So there we will be using this autonomous vehicle type of the robo. Right. Next is the for the handicapped persons. We can also use for the handicapped person, which provides the mobility. Right. And in the planetary exploration, in near the exploration also, generally persons cannot visit. So there also we can use the autonomous vehicle, which becomes one of the most important application. Right. So generally in industrial environment, in military and security application, in the environment which is hazardous to the people, like in nuclear reactor or deep seabed, or for the handicapped persons to provide mobility, we can use autonomous vehicle, or in any particular area where we have planetary exploration, there also we can use the autonomous vehicle type of the robo. Right. Now, based upon the wheeled mobile robo involves kinematics. Right, the wheel mobile robo involves kinematics, dynamics. It also has a control, it has a sensing device, and it has a motion planning and obstacle avoidance. Right. Now, based upon all these constraints, we will be developing a wheel mobile robo. Right, based upon the kinematic movement of the robo, based upon the sensing operation, based upon the motion, based upon the control on the robo, or based upon the obstacle avoidance, we will be manufacturing a wheel mobile robo. Because when a robo is not having a control on itself, what happens? It causes damage or it harms and the other person in its surroundings. So we should have a control on the robo, and the robo should sense what is coming ahead or what is coming below. That is, it should avoid the obstacles around its surrounding, right? As well as it should have a dynamic and kinematic motion in order to move from one place to the other. So considering all these constraints, we need to manufacture a wheel mobile robot, right? Let us take an example of in 1987, Muir and Newman have introduced this wheel mobile robo, right? In 1987, the wheel mobile robo was been introduced with one of the scientists called Newman, where he have manufactured the robo which is used to locomotion on a surface, right? Where the wheel assembly mounted on it and in contact with the surface, right? That is, a robo is been manufactured in such a way that this particular robo, when it is moving, this wheels can come in contact with the surface, right? And other than that, the wheel assembly is being provided in order to have this in order to have the motion to be mounted on its surface, which is having a single point of rolling contact, right? That is, the wheel assembly, whatever is been attached to that particular device, should have a single point of rolling contact with respect to the surface. And here we have three types of wheel mobile robots, that is conventional type, omnidirectional, and ball wheel, right? The scientists have been introduced the wheel mobile robot categorized into three types, that is conventional type, omnidirectional, and ball wheel type, which we will be seeing in the next slide, right? So as you can see here, this is the figure of the conventional type of the wheel mobile robo, where here we have one wheel being attached to the steering motion. Here you can see, right? And this is the pivot motion being taking place. That is, as the pivot or the steering is being moving for the robo, this particular wheel starts rotating. With one is the fixed wheel, and here it is the steering wheel, and this is the caster wheel that is in the A, B, and C position. Here this particular frame will be fixed and the wheel starts rotating. That is, the conventional wheel most commonly used for rotating about the axis of the wheel as well as the steering. That is, when the axis of the wheel and the steering is moving, the conventional type of the wheel rotation will be taking place. It is most commonly used for rotational about axis of the wheel and steering. Now when we come across the omnidirectional wheel, here this is the omnidirectional wheel, where we have the wheel being attached to the active rotor, and this is the hemispherical gear being placed, and this is the propellant, and this is the passive rotational axis, right? Now when we come across this omniball type of the wheel, here this particular type of the wheel is called as the Swedish wheel, right? This particular type of the wheel was being named as Swedish wheel, where the barrels are on the periphery of the surface and it rotates at an axis of 90 degrees. The wheel rotation takes place at an angle of 90 degrees, and not only that, in the barrel rotation, the barrel rotate leads to the sliding of the wheel. When the barrel is being rotating, it leads to the sliding of the movement of the wheel being taking place, where it has 2 degrees of freedom, right? This particular type of the omniball wheel is having 2 degrees of freedom with respect to the wheel and the steering, right? And next, coming to the ball or spherical wheel type, here this particular type of the wheel has 2 axes, right? And it gives a driving and the rotational measurement arrangements, right? The ball or the spherical wheel has 2 axes, which has both rotational as well as the spherical operation being taking place. That is, it is complicated between drive at the rotational measures which will be taking place as per its arrangements. So here we have seen three different types of the wheel mobile robots, that is the conventional wheel, one is the omnidirectional wheel, and the other is the ball or spherical type of the wheel. Now depending upon the axis and the steering movement, these particular wheels movement will be done in that particular robot. Right. Next, coming to the single wheel kinematics. Here we will be seeing about the single wheel kinematics, and we will be seeing about the two wheel robot and four wheel robot system. So when we come across the single wheel kinematics, here we will be having only one single wheel with respect to the x and y axis, right? With respect to the x and y axis, we will be having only one particular single wheel being rotated on the surface, where we are considering as x sine pi minus y cos pi is equal to 0. Right, that is when the wheel starts slipping motion against with respect to the tangent to the path, it is being given as x sine pi minus y cos pi will be equal to 0. That is, the velocity perpendicular to the tangent vector will be 0. That is, velocity perpendicular to the tangent vector will be equal to 0. And we can also tell the non-harmonic constraint cannot be integrated to obtain 0. So the constraint x is equal to q is equal to x comma y comma phi. Right, the constraint q will be equal to x comma y comma p. Now, in order to justify this particular equation with respect to the harmonic nature, how will we justify that? It can be integrated. So this particular term can be integrated. This implies that x comma y comma 0 is equal to 0 with respect to the 2 degrees of freedom, as I've told you, is automatically determining the third. That is, x is equal to y is equal to 0, where phi is fixed, right, where phi is fixed. Now this is clearly false, that phi is possible at 0 comma 0, psi will be possible at 0 comma 0 when we take f of x comma y comma phi is equal to 0. It is not integrable, so we get the equation as x, y or phi will be equal to cos pi, sin pi and 0 into the vector v plus these are 0, 0. So 0, 0 into 1 into angular velocity, right? Angular velocity. So this is how we calculate the matrix for a single wheeled robo. When we come across the two wheeled robo, we take the axis of x, again x, y, where we are taking x sine psi minus y cos psi is equal to 0. There we have taken x sine pi minus y cos pi, right? Here we are taking x sine psi minus y cos psi is equal to 0, where x sine of psi plus pi minus y cos of sine plus pi minus 1 into psi cos pi will be equal to 0. That is, the kinematic equation for a two-wheeled robo will be x, y, psi and pi. That is cos psi, cos pi, sin psi, cos pi, sin pi by 1 and 0 with respect to vector vf, and this will become 0, 0 and 0, 1 of angular velocity. So this is how we calculate the matrix xy psi pi matrix when we have two-wheeled robots been moving on a particular surface that is generally called as a bicycle. For a bicycle, we have two wheels being attached to a cycle, right? So this comes under that particular consideration, that particular example. That is where psi is the orientation of the rear wheel with respect to the x-axis, and pi is the steering angle with respect to for the front wheel with respect to the body. That is, this is the front wheel which we have, where we have an angle of pi, and this is the rear wheel which we have, where we have the angle of psi with respect to x and y axis for the front and the rear wheel. right? Now, when we come across the four-wheel mobile robo, right? When we come across the four-wheel mobile robo, here we have four wheels being attached, 1, 2, 3, and 4. So that particular equation is generally called as steering angle for front wheel is different in terms, different in a turn, right? That is, generally we call this particular type of the steering system as acumen steering system, which is used to avoid slipping. Yes or no? When we compare a four-wheeler and when we compare a two-wheeler, four-wheeler will have more accountability on the ground compared to that of the two-wheeler. Two-wheeler can be easily slipped, whereas the four-wheeler cannot be easily slipped because of its constraint. So here that particular formulation is being taken as squat of pi power I minus squat of pi power 0 is equal to d by 1. That is the multi-axle vehicle, whether it is a truck or whether we take a bus or whether we take a car, that particular multi-axle vehicle will be attached with the trailer. That is, the steering front wheel to the left result in right motion of the wheel on the will be no minimum phase system. That is, it has more analyzed and the model system being taking place, right? And this particular type of the mobile robo we call as a acumen steering type of the mobile robo. Clear? So these are the references which we have gone through. Right. So in today's class, we have seen what is the importance of the wheel mobile robo, what are the various application, where we can use this particular wheel mobile robo, and what are the various categories which come under wheel mobile robo, and what is the use of a single wheel robo system, what is the use of a two-wheel robo system, and how the matrix is being written for a single wheel robo and a two-wheel robo. And we have also seen about the four-wheel robo and the difference between a two-wheel and the four-wheel robo, what is the accountability and what is its use and what are its benefits. So this is all about the wheel mobile robo. So in the next class, we will be dealing with few problems related to this. So signing off for today, Dr. G. Hima Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.